Okay, I just want to brag about my math skills for no reason. So this right here, look how thick, well, it's not too thick, but this is all the times I have sat down and done math in my free time. This is from freshman year of high school through junior year of high school. The last time I sat down and did math in my free time was junior year of high school, and I am now a freshman in college. Anyways, I wanted to look through here. Let's see. I'll bring up anything interesting when I see it. Oh, this was junior year of high school. I made this worksheet. Here's the answers. And I gave it to a bunch of people in my class. And only one person was able to solve 1B. And that was Logan Keithley. Nobody else was able to solve 1B. But the questions don't necessarily get harder as they go on. They just get more complicated. Breeding cats. Yes, I made an equation for breeding cats. If you have a certain amount of male cats, certain amount of female cats, a male cat can impregnate more than one female cat. So I made an equation, and where is it? Aha. So these are like what this bracket thing means. Up like that, up like that. That is rounding. It's called ceiling. So you round up to the next whole number. And modulo is like division, but it's just the remainder. So it's the remainder of, I think it would be this over this. I can't remember. This has been a while since I made this. But yeah, that's the final equation. If F means female cats, M means male cats, C would be the total afterwards. It was some silly stuff I did. I'll put that over there. Actually, I'll put it on top of... Yeah. Oh, I don't want to get this unorganized. Hold on. I'll just do that. I want it to be in the same order. Oh, these equations. So what I did is I did factorial, but with different offsets. So this equation right here, actually, I have as my phone background. This equation, 7 comma 2. So what it is it's x factorial. So starting from 0, every whole number. Here would be starting from 1, every whole number. Here would be starting from 2, every whole number. And so on and so forth. Here, we start from 0, but it's every 2 numbers. Here, it's every 2 numbers starting from 1. Here, it's every 2 numbers starting from 2. And as you can see, it gets more and more complicated as you go down. But there's a pattern. So here we have 7 factorial at the end when we start from 7. And here we have 5 factorial at the end when we start from 5. So it's a pattern. So you can link all the odd ones up together. So 1, 3, 5, and 7 are all similar. 0, 2, 4, and 6 are all similar to each other. So there's 2 separate patterns going on here. In this, I wasn't able to completely solve. I remember sitting... So it took 4 days to get to here. A few hours each day. It took some headaches. This was right before junior year of high school when I did this. But I wasn't able to solve... Let's say we're starting from 8, but we're doing every 3. I wasn't able to solve that. So this is how far I got. Okay, so here, from the worksheet I showed you, the equation to solve all those problems is this. This is my favorite equation. Y equals L plus x minus 1 factorial over x minus 1 factorial L factorial. This is my favorite equation. And, well, I made it, I think it was junior year of high school. I think this is the last time. It was the last time I sat down and did math in my free time. I just made the equation. My second favorite equation is this right here. This is the basic summation equation. And I made this equation in 6th grade. Because I wanted to know what is 1 plus 2 plus 3 all the way to a trillion consecutively. And I had the question 5th grade, and I solved it 6th grade. So this is my second favorite equation. If you notice, if you plug 2 as L into this equation, it actually gives you this. So this is why this is my favorite equation. Because it technically is the same thing, but just L is 2. If you plug in 3 for L, you get this, which is linear summation of linear summation. If you plug in 3... if you plug in 4, you get this. If you plug in 5, you get this. If you plug in 1 for L, you just get a linear equation. So L here on the side, as it goes down, L stands for layer, and the layers increase. And what is this? Oh yeah, this is how I came up with the equations. What does this say? Yeah, L equals whatever as it goes down, and it has the multiplier, which is the ratio. And it's all over here. So this is the pattern, because this up here, boom, 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 whatever. Next thing, what is this? I don't know what I was doing. Oh. I don't know what I was doing here. Anyways, let's move on to, is this interesting? Let's see. Oh yeah, this is where I had this equation. So here we have y, and we have x, and we have multiplying. So it's 3 times 6 times 9 times 12 times 15. So this is the factorial thing. This is as far as I got. I was not able to solve. So these blanks here, they don't have what it's equal to because I wasn't able to figure that out. I spent about 4 days on it. I probably could figure it out if I put time into it, but I don't want to. Because, I don't know. I might in the future, if people convince me to do it. And here is some of the work I did for some of the others. So 7 times 9 times 11 times 13 times 15, on and on. Every odd number starting with 7 is that equation. Yeah, it's that equation right there. What's over here? Oh, it's more work. I went through a few pages there, trying to figure it out. What is this? Oh, this is when I was learning trigonometry, and I was getting upset because I didn't understand trigonometry. And I tried to make my own trigonometric functions. So I did like 8, side 8, sid, sec, or whatever. I don't remember. But yeah, I did not like trigonometry. Trigonometry, I am not that good at, compared to algebraically. Algebraic skill I have, but when it comes to geometry and trigonometry, I just... I don't know. What is this? Oh, L is layer. Yeah, this is my favorite equation. That's what it was. And I did V instead of X. Interesting. So V stands for value. So yeah, I probably did that junior year of high school. That's how much we've gone through, and this is how much that's left. Why is this all crumpled up? I don't know what I was trying to do here. If anyone can make sense of that, tell me. It's crumpled up, so I probably tried to throw it away, but then changed my mind. What was I doing here? I don't know. And over here, some stuff. Oh, this is when I was trying to make the biggest number possible. Where's Google? Yeah, Googleplex, Googleplexian, Googleplexianthinate. And I tried to make the biggest number possible because I was bored. I don't know. Tell me if this is bigger than, like, tree 3 or something. Because I did so many arrow things. I made my own notation. Okay, what is this? Pascal's triangle, but it's a pyramid? Oh yeah, Pascal's triangle. I'll talk about it when I get to that. Yeah, so there's something really cool I could show you, but once we get to it, I'll talk about it. I don't know what... oh, I remember what this is for. I think. Yeah. I don't want to go into detail about it. But this is just like another way. Let's say you have 5x plus 3 equals 8x minus 6, and you want to find what x is. You could use this equation as an alternative way than just adding and dividing to solve for x. It's just an alternative way. I had that pattern down for a while. Okay, now Pascal's triangle. Now I could talk about this. Yeah, so Pascal's triangle, so I learned Pascal's triangle when I took Algebra 2. Was that junior year of no, that was sophomore year of high school. Yeah, it was sophomore year of high school, and so this was before sophomore year of high school. What I was trying to do is I was trying to find the standard form recursive formula for, let's say, x squared or x cubed, x to the 4th, all the way down here to x to the 10th. Standard form recursive formula. That's what I was trying to find. And I made Pascal's triangle before we learned it in class, but I didn't see the pattern. Because 1 plus 1... Wait, yeah, 1 plus... Where's the pattern here? 1 plus 1 is 2. Let's say 15 plus 20 is 35. So you go left, right, down. So here's 7, 21, 28. Let's try it over here. 126, 84, 210. 126, 84, 210. It's that same pattern. That's Pascal's triangle for you. And I didn't see the pattern when I was making this. But when we learned Pascal's triangle in class, I got super happy and I brought this to class. Just to brag to everybody. What is this? I probably asked some people to give me a random set of numbers, and I would make an equation out of it. So, just using my own math skill there, just nothing on the backside. What is this? Oh, this is the standard form recursive formula for x to the 5th power. This is how you would put it in your calculator. So plug in 0 and hit enter, then get ands, do this to the 4/5, this to the 3/5, this to the 2/5, this to the 1/5, and then this. And if you hit equal, you will get every power of 5. So if you hit equal once, you should get 1. If you hit equal again, you should get 32. And if you hit equal again, you should get 3 to the 5th power, whatever that is. So this was just doing that. What's a simpler one? Yeah, here. This is the standard form recursive formula for x cubed. So it's ands plus 3 ands to the 2/3 plus 3 ands to the 1/3 plus 1. If you plug that into a calculator and hit equal, it will go through all of the cubes, the perfect cubes. So it would be 0, 1, 8. What's 3 cubed? 27. 4 cubed, I think, is 64. And it should do that. This up here is the standard form recursive formula for x squared, just the same thing. Ands, 2 root ands plus 1 should give you every square. Yeah, notice how this is the 3rd level in Pascal's triangle. And these numbers, 1, 3, 3, 1, that's the next level of Pascal's triangle. 1, 5, 10, 10, 5 is another level of Pascal's triangle. Here would be the standard form recursive formula for x to the 4th. 1, 4, 6, 4, 1. So it's each layer of Pascal's triangle is the standard form recursive formula for that power. What is this? That's the same stuff. Here, I tried to graph on a logarithmic scale powers. So this would be x to the 8th. That would just be x, and this is what it looks like. And it's equal spacing between all of them. It's equal spacing. It's a constant multiplier. Okay, next up. Probably asked some people to give me random numbers, and I made an equation for it. Let's go through it a little bit faster. This video is getting quite long. Nothing important. Oh yeah, this equation. I like this equation. This was 8th grade. I made it before 8th grade, but then I forgot, and then I made it again. So, because I had thrown out all my papers, I think it was like sometime around 8th grade. I didn't keep well track of it, so... But that equation helped me in class a little bit. Here, I don't know what I was doing there. Why is this folded? Any backside? No. What is this sheet? This is all that's on it. It's just this and it's blank on the other side. No, it isn't. Oh, this thing. Yeah. So I was trying to find out what is the most efficient way to run an arm wrestling tournament. So I don't know how to understand this. I was trying to figure out how to do pairing up, and yeah. How much left do we have to go? That's still a lot, it looks like. Oh, I tried to make an equation for vaccines, whether they're worth it or not. So mortality rate of disease, mortality rate of vaccine, vaccine effectivity, life expectancy, vaccine effective time. And where's the equation? Yeah, there it is. Y equals NVQ over C. It's just an estimate. It's nothing exact. But I made that equation. Oh, this is the arm wrestling tournament thing again. Just trying to find the most efficient way to pair people up. What is this? I don't know. Oh yeah, 1/4 n squared over tangent of 180 over n. I made this freshman year of high school to help in geometry because I was annoyed with having to find the apothem because 1/2 ands. This a is the apothem, so instead of the a, I got rid of the a. And if you just use n and s, this would give you the area. So feel free to use that if you're a geometry student. I don't know what I was doing here. It's blank on the other side. I don't know. We're getting close to the end. We're getting there. Oh, what is this? Looks like the 1/4 n squared over tangent of 180 over n, but different. I was doing something with that there, definitely. It's been so long since I've done math in my free time. I should get back to doing it. I don't know what that was that I just looked at. This has scribbles all over it. Oh, x squared plus x over 2. My second favorite equation. And the last one is wet. It got wet for some reason, but this is the third to last piece of paper we're looking at. So what is this? Oh, this is finding when L is 4 from my favorite equation. Remember x plus L minus 1 factorial over x minus 1 factorial L factorial? When L is 4, it's this. Or something. Yeah. This was me figuring that out. Second to last piece of paper. Yeah, this is the pattern. This is how I figured it out. This would be 5. So when L is 5. And I got that multiplier. What is this? Huh. Oh, there's stuff on the back. Okay, last piece of paper. That's when L is 3. This is wet for some reason. It got wet. I don't remember exactly what I did. And it's also crumbled up. So this is the oldest paper I have. So this had to be freshman year of high, probably even 8th grade, actually. 8th grade sounds about right, maybe. This is the oldest I have. So yeah, that's all of them. Thanks for watching.